Hey everyone, welcome back. So in this session, we're going to talk about how the right architecture can help you migrate to Kotlin and make it easier in that way with Nico Krijnen. Enjoy everyone.
Thank you. Welcome everybody. So I'm going to talk to you about architectures and how those can help you to migrate to Kotlin. And not just architectures, just a lot of techniques in general. So this talks about migrating. And migrating to Kotlin is not about greenfield projects, right? I'm assuming you're coming from typically a Java code base. And to be clear, this talk is intended to inspire you to try out some of these things. It's not by no means the only way, right, to do this. The beauty of code is that there's endless possibilities, so there's always endless opportunities to learn from each other. So if you have other ideas or ways of doing these or helping migrate to Kotlin, come see me after the talk and let's have a chat. Okay. I am Nico Krijnen. I work at Luminous, and there I try to solve complex problems in simple ways. And you may be wondering what gives me the capacity to talk to you about this subject. So over the last years, I've worked on a fairly large code base, 14-year-old legacy code base, Java, and we were actively modernizing that code base, taking it to the cloud, introducing Kotlin, but in general just trying to improve the quality. And in that way I learned a lot of these things, experienced them firsthand, so I thought it's worth sharing that with you guys. So starting with the question, why would you migrate to Kotlin? And this is a topic on its own, so it's really something for another talk. But I still want to see if we can get 2 highlights. So anyone, what would be your top reason to migrate to Kotlin?
Complexity?
Less complexity, that's always a really good reason. Yeah? Other things?
Better defaults for things like nullability and final.
Yeah, defaults for nullability. So I'd say nullability, for me, on its own would be enough reason, to be honest. I mean, the most common error, and don't take my word for it, I mean, these guys, OverOps, did some research on the error data that they have for the apps that they run, and null pointer is definitely at the top of the causes of exceptions there. And we've all seen them, right? So getting rid of this whole class of errors, I mean, that's really, really worth something, worth putting some effort in. So, another reason. What else could you want Kotlin for? Extension functions. You just saw. You have to use them always, but yeah, maybe. I really like them in the right place. Yeah. Okay. So I say immutability. Immutability is really, really valuable. Most of our apps are concurrent or parallel, have parallelism in there, and like any web app, typically a backend, there is a lot of concurrency there. So when you have that, there's one thing you want to avoid, and that is shared mutable state. And don't take my word for it. Let Kevin Henny convince you. He has an excellent talk. Look it up. It's about this whole problem with shared state and concurrency. So if you have both shared state and your state is mutable, then you're in that like red zone, right? The letters are red for a reason. So that's the place where you don't want to be. You're in trouble. So you can do 2 things. You can either not have concurrency, right? But that's typically not an option. So the other thing you can do is make your state immutable. And Kotlin as a language really helps you with that, right? All the data structures, they are immutable by default. The way you use the language really makes it easy to work with these immutable structures. And that's very different from your Java code base, right? Where everything is mutable by default. So this, I think, is also a really good reason to start using Kotlin and use it in the right way, right? Use it with those immutable structures. Okay, so how hard can it be to rewrite Kotlin, right? There is this nice thing in ID, and we're on a JetBrains conference, so yeah, that's what's in here. So there's this nice convert Java to Kotlin thing there. So is that a good idea? I mean, just a push of a button, right? That's really tempting. So No. It's tempting, but you'll miss out on all the good stuff, right? This converter, it'll convert your Java code, but it'll take all the immutable data with it. So that's not good. You want this. You want to do it the right way. It also keeps all the null stuff in there, right? You have null saved with Kotlin, but you have to write it in the right way. If you just convert your Java code, it's going to have nullable types all over the place. So this is not a good idea. So that means you have to rewrite. Oh boy, we have to rewrite. So first think to yourself, what's the effort? Right? What is the effort of doing this rewrite, and what's the business value? Is it wise? Is it even possible? And again, this is not the scope of this talk because that's a subject, a really big subject. But let's talk about, let's say, a simple microservice, right? And depending on who you ask, there's a lot of definitions for microservices out there. But say the definition is it's micro, it's small. You should be able to rewrite it in 1 week. Otherwise, it's not micro enough, right? So if that's the case, then rewriting a service in 1 week to Kotlin, that's totally doable, right? And with all the benefits you'll get, I'd say it's a no-brainer. Just go for it, right? But many code bases, and I'm pretty sure a lot of you have these, they're not small. They're not that micro that you can rewrite them in 1 week. So what do you do then? So you can't neglect the fact that you have to build new features. And if you're building this whole new Kotlin thing, but you're building features in the old one still, you also have to port those features again. You're just making the problem bigger. So this is definitely not the way to go. Instead, what you want to do is take small steps and keep integrating the things you're doing. So you're rewriting you're slicing up a small piece, you're rewriting that to Kotlin, but you keep it integrated with the whole thing, which means you have to use Java and Kotlin next to each other. And that's actually quite good because Kotlin has excellent interop with Java. So we did this in the project we worked on, and it worked really well. Essentially, we rewrote new features in Kotlin, and then we also rewrote everything that we touched when we made bigger changes. So let's talk about the techniques. So these are some of the techniques that helped me out on the project we worked on. And they help me out to make small steps and also improve the code quality and modernize the whole thing. And to be honest, Kotlin there was not the goal, right? It did really help us to clarify the intent of the code, to communicate, because Kotlin is quite expressive. And you may also be wondering, like, reading these techniques, these are not Kotlin specific, right? You can do these things in any other language, like you can do them in Java or in TypeScript or so, and yes, you can, and you should, right? But Kotlin does, on my experience, Kotlin helps you with some of these, and it's a very good fit in a lot of cases. And I'll show you bit by bit. So I want to talk about hexagonal architecture, but before we do that, we have to make a side step. We're going to go into direction of dependency, because this is something you'll have to understand. So let's take a traditional 3-layer architecture. An architecture like this is not about the 3 layers, to be honest. Right? It's about the direction of dependency. It's about making a restriction on where, what kind of dependencies you can introduce. Right? And here it means that a top-level module can only import stuff from the module below it. Right? You can only depend on something from the module below it. And you cannot import something or cannot depend on something from a module above you. Right? That would violate this architecture. The trick, though, is you can control this. But how do you do that? So let's start with this, like just 2 blocks. It's easier. How do you inverse the dependency? So there's a small trick here. What you do is you keep these modules, but in this case, the logic module, instead of importing something like importing your repository and doing stuff with it, you introduce an interface, and you let your repository or the DB module actually implement that interface. And if you do that, which we'll look at in code, is exactly what will happen, right? So this is the first situation. where you have a small service, so this is a piece of logic, and its importing is depending on a database, and in this case, some API that it needs to call. And it's just calling these APIs, right? It's importing them, it's depending on them. It's actually import them from, in this case, what we call an infra package, so an infrastructure package with these things in there. And we want to get rid of those imports, right? In our business logic, we don't want to have these imports. So we create two interfaces that describe the needs that we have from the outside world. And then on the DB side, on this repository and in this in this SMS service, we implement those interfaces. And as you can see now, the imports are the other way around, right? Our database and our SMS module, they depend on this piece of logic and not the other way around. Okay, so maybe a lot of you already know this trick, but I think it's good to recap just so you're on the same page. So hexagonal. This is also called ports and adapters, or sometimes people call it onion architecture. The naming has some nuances, so it's not exactly the same, but the idea is very similar. And you often see these in combination with domain-driven design concepts. And this diagram is actually a really good diagram of hexagonal architecture, but if you don't know the concepts, it really seems a bit daunting, right? There's all these blocks and things and stuff going on. It looks really complex. The nice thing about it, it's actually not that complex. The real core idea here is really simple. The core idea of hexagonal and onion architecture is you have an inside and you have an outside. And this inside part is where your business logic lives, and the outside world is all the communication with the rest of the world. So your API, your database, your third-party services, all that stuff that you need to communicate with, that's on the outside. And then with hexagonal, the dependencies, which we just talked about, can only go inwards. So your domain model never, like your business logic model, that's part that never has any dependencies on any of these other things. Which probably means that in some places you'll have to use this interface trick, right, to make the dependency go the other way around. That also means your inside, your business logic, it doesn't need to be aware of your web technology, it doesn't need to be aware of your framework, right? It's just pure code. And that's quite powerful, which we'll see later on. So there's quite some benefits here. So you get more, it's more modular, there's a lot more separation. It allows you to swap implementations of these outside things quite easily. So if you upgrade to a new version of your framework or a new version of your database, you can just create a new implementation for it, and when you're ready, you swap them out, and you're using the new one. And your business logic, if you do it right, doesn't need to change at all. There are some trade-offs, though. So it means that you have to create those abstractions, right? You have to create these interfaces, and it's often quite hard to not leak details of the specific database you're talking to in this abstraction. And obviously, if it's leaking those details, it's harder to swap it out later on. So that can be quite an investment upfront for something you may not ever swap at any time, right? So think about, is it worth it? Do you need, how likely is it that this piece of code is going to change? And do you want to make that investment to make it easy to change later on? Don't add complexity like these abstractions if you don't need them, right? I'll come back to this later on as well. But apart from swapping swapping dependencies, you can also have some other benefits here. So the inside part, which probably should be the most important part of your code base, right? That's really where the code lives that makes your app unique, makes it the app, well, be the app that it is. That part with hexagonal has no dependencies on anything. And that means that part can really focus on the problem you're trying to solve. And it also means that it's really easy to test, that it's really easy to change, and also because it's so isolated, it's really easy to reason about. And all those things help to keep it maintainable, etc. So then how does this architecture help you migrate to Kotlin? And I think the most important part is that this really important part of your code, this logic part, right? This business logic, that is isolated with hexagonal, which means you can test it on its own, and you can write just that part in Kotlin, right? Without affecting much of the other stuff. If you already have this architecture, then that's the most important part, the part where you probably going to make the most changes. So if you rewrite that, you're going to have most value of rewriting it. The rest can all remain just Java, your existing framework, until you're ready to change it, right? Each adapter, so these outside blocks, they're called adapters in hexagonal. Each of those, they can live in their own module. So that means you can swap them to Kotlin, each in their own term, when you're ready for them, right? And I think all this isolation, all this modularity really helps you to do this big rewrite in small steps. So how do you start with something like hexagonal? So this whole thing, this picture you saw at the beginning is quite daunting, right? There's all these things out there. Do you really want to start doing that straight away? I'd say where you really want to start, where the real value is separating that inside and that outside, right? So you create a module or a package for your domain model. You create a module or package for your infra code, like all these outside pieces, and you separate these. You make sure that the dependencies can't go the wrong way by making them two separate modules, and that's already going to give you a lot of value and force you in the right direction. And then once you get used to how that works, then start looking into other stuff about hexagonal and introduce the other concepts as well, bit by bit. So just the inside-outside separation, that's a really great start, and it's going to give you a lot of value straight away. Okay, next technique. Vertical slice architecture. And in my experience, this might even be more useful than hexagonal. So back to our traditional three-layer architecture. So vertical slice is pretty much what the name suggests. You take vertical slices over these layers, and you create a slice for every feature in your system. And instead of the usual approach where you have controllers in your API level, and you have some components in your logic and some repos in your DB layer, and they're all, like all the repos are in one place and all the controllers are in one place. In this case, all the code for a feature, like your controller, your logic, your DB model, they're all in like a package for that feature. And so you keep essentially the code for all the layers together for that one feature. And that allows each feature, in theory, to have its own architecture. Right? So depending on the simplicity or the complexity of a feature, you can choose an architecture that fits that complexity, that level of complexity, or just keep it really simple. And then you may ask, okay, is it really wise to mix architectures in one system? And I'd say that depends. Consistency in a system is quite important, so I actually wouldn't do this typically. Right? It really depends on how different the features in your system are. Are they really that different that you need this? Just don't mix an architecture in just because you can, right? Don't do that. But it does bring us to more sort of benefits of this architecture. So you get real clear separation, again, of separation of features in this case. And that means that code that naturally belongs together actually is really close together in your code base as well. And that's something we call cohesion. And you may have heard of something related to that, which is low coupling, which is also something you get from this approach. And those things are both good. You have to look it up, but yeah, trust me, they're good. So right, different features don't depend on each other if you do this right. So you hear it depend. This is all about managing dependencies, like we saw earlier, right? And a lot of things in software are about managing dependencies. Having each feature isolated from the rest means you can keep the complexity of each individual feature to a minimum. And I'm all about minimizing complexity, so that's a good thing. And it also means you can evolve every feature on its own pace. Right? If one feature is very actively developed and it's growing very rapidly, and to change this architecture, go ahead. If the other features stay behind and you have just some simple CRUD stuff there, it's fine. Just keep them like that. And also means you can introduce more advanced techniques like the hexagonal when you need them for that feature and not for the whole system at once. So you can probably see where this is going. So this makes it easy to keep an overview of a feature, right? Because the code is close together, you can see it. It means it's easier to refactor because you can see which pieces touch which other pieces. You can understand where things are being used. And then, obviously, most important, it allows you to take small steps, right? Because everything is isolated from the other parts, and you really minimize the blast radius of the changes you're doing. So this all gives you great confidence to change one slice of your system without breaking any other part, right? And this is really a thing that in big code bases is often something that people fear, right? If I change this thing, what else is going to break somewhere on the other side of this application? And this isolation really helps you prevent that problem. And if you're working on a monolith, this helps you make it more modular. And in turn, if you really need to, you can probably quite easily extract one of these features into its own microservice if you ever see a need for that. So apart from those benefits, which is all good stuff, right? So how does this help you migrate to Kotlin? So having each feature isolated means you can introduce Kotlin to each in turn. And the isolation, again, allows you to use new architectures like hexagonal, one feature at a time. And all these things allow you to take small steps. So next, this is not really an architecture, but it's a technique that's very valuable. It's called value objects. And you can use this in any type language like Java or Kotlin or TypeScript. So looking at a simple class, what if someone would change the constructor parameter order here? What if they would do this? Ooh. Well, actually, if they use IntelliJ, and there's a really nice refactor signature tool, it's the best out there. I don't think a lot of people know that or use it. That's really good one. If you use that one, you're all safe. It's no problem. But if you don't, and someone makes this change, then probably all over the place it's going to be IDs passed in as names or names as IDs, and you're going to have very subtle bugs that are really hard to find, and oh man, you don't want those. So what instead? We introduce types, right? You have a type for each value that you have. So instead of using a string or another primitive, you actually wrap that value with a small class, really small, that represents their meaning. And these strong types make it really hard to make mistakes, right? I mean, there's no way if you swap them that your compiler is actually going to complain. You can't compile the code until you fix all the swap places where it was used. So if you don't do this right, you also add a little bit of validation, because typically these value objects they have is not just a string, right? It's a product name, and product name shouldn't be empty, for example. So you add a little bit of validation, and if you do this right, you never have to worry about validating these values anywhere else, right? Instead of having this string and having to know, is this being validated before? Can I use it safely? I don't know. No, you know, when it was constructed, it was validated, and wherever you are now in your code, you can use it. It's safe. Another thing about value objects, they are always immutable. So we already knew why that's good, right? And then a tip from a really great programmer I worked with, Martijn Piets. He said, why don't we handle this translation really on the outer edges of our system? And I'm not talking about like outside of the core in this DB stuff, no, outside of that even, right? So let's look at the JSON serialization we have in our API and in our DB layer. And let's add some serializers that understand these value objects. And then whenever a value comes in, it just translates it from the raw JSON into the value object. And we just use in the controller, we use our value objects. So it means everywhere in our code base, we're only using these value objects. There's no strings anywhere. And it means that the validation is all done on the outside layer, so you can know that it's valid. It also means the translation is only done once, when it enters your system. Right, or when it leaves the system. So you never have to do that conversion all over the place. And I think all these things, they really give you a lot of confidence about what values you're talking about and that they're valid. So how does this help migrate to Kotlin? I mean, this is nice, all this stuff, but you know, we're talking about Kotlin here. Value objects in Kotlin are really easy. It's just a few lines of code typically, and you have a value object. And there's even some stuff recently released that makes it even easier. And again, as I said before, these things you can introduce them really in small steps, right? You can take one place where you have one specific value, and you can change it to that value object, like in the middle of your code, and then you can work your way outwards in small PRs to introduce it in other places until you reach that outer layer, and then that value object's all over your code base. And then you go for the next value object. And you only do this, you don't like introduce all the values objects throughout your whole system at once, right? You do this whenever you create a new feature, or whenever you touch a little piece of code and you think, okay, this really could use a value object here, then you introduce it, right? So you take these small steps. So next technique, encapsulation. So it feels a bit like we're reinventing the wheel in software engineering every few decades. And I think encapsulation is one of these really undervalued techniques. In essence, it comes down to preventing others from using the inner details of your class or your module. And if a user of your code wants to know something, they have to ask you. And you, with your own data, will figure out the answer and give them the answer, but they're not allowed to get to your internals. And the more specific the questions are that are asked from your code, the better. And we'll see why. So let's look at some code. So take the money from example from earlier. What if we expose the inner values or create getters? The raw values will be used, right? Someone will write some code and will do their own calculation with these raw values, and well, what could go wrong? The problem here is that the raw values will be used in a lot of different places. Maybe the same calculation is done in different places, but in different ways. And if you want to change or make a fix, then you have to find all the places, hope you find all of them, and then make sure they're all consistent again. So this is really hard. It makes your code really hard to change. So what if instead you keep the data to yourself, right? What if instead the code has to ask you a question and you give it the answer, right? Then you don't have to expose these internals. You make them private, and you force yourself to solve the problem in the right place. And then what is the right place? That's always something you have to figure out. So always ask yourself some questions. So what question should be asked of an object? Right? Think about that. And then also think, should that object be the one to answer? Right? Does it have the data needed to answer that question? If it's not the owner of the data, then probably you should delegate it to the part that does have ownership of the data. So doing this properly really gives you a lot of benefits. Again, it limits the blast radius because all this stuff is private. You can change it freely as long as you can answer the same questions. You can change whatever you want. It also allows you to take small steps, right? You have, if you do it right, you create all these small bits of encapsulated code all over your code base. Like following this sort of good old OO principle, the result is that you have like nuggets of encapsulated code all over your code base. A bit like chocolate chips in a cookie. And these characteristics make it really easy to migrate all these small pieces to Kotlin. What we actually did is we introduced a lot of these encapsulated behaviors as Kotlin code, and then we started using them in the rest of the code base. And actually, while writing this new code, we typically did it, as I said, in Kotlin. We also used TDD there to make sure the behavior is correct. And we also did it as pair programming to make sure that we really think about these things correctly. So paying attention to those, and then after the base objects are created, then we introduce them in all the code base in small bits. Okay, to close off, some tips around testing. Having a good test suite is really a big enabler for being able to make small changes. And it also means that you have to have good tests. But what are good tests? So a good test suite gives you confidence that you don't break anything, right? And it gives you that confidence in a timely fashion. So if you find some of these things, and I'll go through them, you have to be ruthless to them. You have to throw them overboard, kick them out, right? Because these things are unacceptable. So flaky tests, they're just noise. Like this test that randomly fails every now and then. You never know, like, did my build fail or not? I was just this random test again. I'll just rerun the build. No, don't rerun the build. Ignore the test for now and create a story on the next sprint to fix it, right? But you disable it straight away because it's just noise. It's getting in the way of you making progress. The other one, slow tests. Having fast feedback is really important if you want to take small steps. So make sure you run your tests in parallel. Spin up multiple environments. We have the cloud now, right? We can spin up a new environment for every commit and have it run the integration tests, and another commit can spin up another environment. You don't have to wait, right? There's no limited capacity. Just go. And these things really help you to not have this sort of slow test hold you down. Bad isolation. Right, one test influencing the other, often seen in combination with flaky tests. So these are just horrible, right? It's really hard to figure out, okay, did my test fail because it's failing, or did another, or it failed because the other test changed some data? So doing this parallel stuff, right, running tests in parallel, is really hard if the tests are influencing each other. So really make sure you isolate your test data and your tests. Create a separate tenant for every test if you can. Make it that tenant creation really cheap so you can do it for every test again and again, those kind of things, right? Or just have proper unit tests, usually pretty fast and isolated. A test with no assertions. Have you seen those? I have, sadly. So when do these pop up? Well, typically when you have someone that introduces code coverage metrics and they think it's really important, right? And then people start writing code so that the code coverage goes up. But you can do that without doing assertions, right? You just execute the path and it'll up your coverage. So that's where I saw these things. But do they add value? No, because they don't tell you when it breaks. So what can you do with these? Exactly, one button, delete. So delete them, just forget about them. If you want that piece covered, just write them again. And then tests that are testing the implementation details of your class. The purpose of tests is to make your code easier to change, right? To make sure that you don't break existing behavior. If your test looks or knows too much about the inner workings of your code, it means you can't change the inner workings of your code, right? Which means you can't change your code. So a test that knows too much is holding you back from what it's supposed to do. So that's really bad, but a lot of tests are written that way. So really be conscious about it. Make sure that your test just looks at the outside interface of your module, and that's the part that it tests, right? That's the part that it talks to. And the inside part should be changeable without the test breaking. So how does Kotlin help with test? And we already saw a nice talk about this. So new code, as you've seen, you can write in Kotlin, you do TDD, you write a nice isolated domain model, use pair programming, all those kind of things, right? And that gives you really good tests typically. And test code, just like production code, should really be very readable. Again, this also came back in the previous talk, right? So don't treat it as, oh, it's just test code. No, test code really has to be readable because it's essentially explaining what your system is supposed to do. And you're going to be really nice to your coworkers and your future self if you make sure that 1 year from now you can still understand what your system is doing, because I'm sure you will have forgotten all the details. So, and in this case, Kotlin really helps with the expressiveness, right? Kotlin is a really expressive language, and as you can see, you can use all sorts of nice things to make your test code really readable. And I think really Kotlin shines in that compared to something like Java. So writing new tests, just go for Kotlin straight away. It's like a no-brainer. And then you can use some DSL stuff there to make it nicer. I say don't take it too far, but a small DSL really helps you express the scenarios that you're testing for your features. And look into BDD, right? That's all about scenarios and readable stuff, etc. But these DSLs can really bring you a long way there. And the result is extremely readable tests. So let's see. No, I'm not showing code because we don't have time for that. You saw some code in the last talk, because that's really a topic on its own. So what if you have old tests, like an old Java test suite that's testing your API or whatever? You know, it's a real big, slow chunk. Don't throw it away. It's really valuable, especially if it's testing like the outer edges, the API or your facade. It's going to help you, in not breaking existing behavior, right? So don't touch them. Don't rewrite them to Kotlin. Just keep them the way they are. They're testing what you, so that you know that your code's not breaking anything. And then rewrite your core to Kotlin with confidence. And what if you have no tests? Yeah, that happens too often. So yeah, it's a bit cheesy. I can't make it nicer. Start writing tests. That's the only thing you can do. There's a really good book, actually a well-known book from Michael Feathers. It's called Working Effectively with Legacy Code. And he says legacy code is code without tests. That's his definition. So his advice, again, is just build up tests, start building up tests, build up your confidence, and then start changing your code. But that leads to a nasty paradox. Because as you all know, if you have untested code and you want to write tests for it, you're going to have to change the code. Because untested code is not easy to test, typically. So you can't change the code, because you first have to create tests, but to change the test, or create a test, you have to change the code. So, man. But, I mean, luckily, we're not the only ones out there with legacy code. There's more people with advice on this. There's a good ebook from Nicolas Carlo. He summarized a lot of advice and techniques on how to change legacy code safely. So definitely look this up, and it's really going to help you out. So recap, we have a number of techniques that help you migrate to Kotlin. And you may be wondering, well, this is not limited to Kotlin. These things can work in any OO language, and that's true. And you should use them. You should use them already in your Java code base, so it makes it easy to migrate to Kotlin later on, right? So these things are really techniques that help you make big changes, like migrating to Kotlin, but make them in small steps. And Kotlin helps you with these techniques, because these techniques are easier when you use Kotlin. And as you may have noticed, there's a recurring theme here, and that's what I'll end with. Take small steps. Thanks. Do we have time for questions? 2 minutes, cool. Any questions?
Yeah, just I guess a question for clarification. The value objects that you mentioned, where should I define those? From what I understand, you meant that they should be part of your domain model, or at least the physical classes that represent it, and then you need that to combine that with the sort of the dependency inversion that you discussed before, so that all of your outer layers can look at them and use that same type. Is that what you meant, or?
Not necessarily. So you don't. The two concepts are separate from each other. You can use value objects without doing hexagonal at all, or you can use value objects. You just put them somewhere where your code can access them, and you're fine. So if you can make a library module out of it. I just put them somewhere. Like if you have this centralized domain, that's a good place to put them, right? Because that's accessible by all of your code base. But yeah, if you need a value object that's just used in a controller, then just put it there, right? Limit the place where it's being accessed, make the scope small as possible. And yeah, that's a good place to put that one. But usually the domain is the place where you put them.
I think that's it then.
Cool.
Thanks, Nico. Thanks a lot. Give it up for Nico once more. Cool. We'll be back in 5 again. For the people in the chat, I saw some questions. I'm going to give you the tablet to Nico, so maybe you can answer those as well. And then we'll see you in 5 again. Cool.